So the next question of Code Forces round 918 Dev 4 is romantic glasses.
So in this question, we are given with an array, which is A1, A2, A3, all the way up till AN.
Yeah.
Right. In this array, we are supposed to find if there are any two indices L, R, such that 1 is less than or equal to L, is less than or equal to R, is less than or equal to N, where we can divide the array into two parts.
Yeah.
The first part is AL plus AL plus 2 plus AL plus 4 all the way up till AR, which is equal to AL plus 1
Yeah.
plus AL plus 3 plus AL plus 5 all the way up till AR minus 1.
Yeah.
Right? This is possible when L and R have same parity.
Same.
Right? If they don't have same parity, then the condition that we should satisfy is AL plus AL plus 2 plus AL plus 4 all the way up till AR minus 1 should be equal to AL plus 1 plus AL plus 3 plus AL plus 5 all the way up till AR.
Yeah.
Right? The second condition, we should make sure that the second condition holds true when L and R have different parity. And if they both have same parity, then first condition should hold. Right? Yeah. So basically, in our array, we should figure out that is there any L, R pair which satisfies this condition. If we have a pair that satisfies this condition, we should print yes. Otherwise, we should print no.
No. Yeah.
So looking at the constraints of the question, we are given that we have t test cases, t ranges in the range of 1 to 10 power 4. We are given that n is the size of the array, where n is in the range of 1 to 2 into 10 power 5. We are also given that array elements ai are in the range of 1 to 10 power 9. And it is also given that sum of n over all test cases does not exceed 2 into 10 power 5. Yeah. These are the constraints of the question.
So basically in this question, firstly, let's observe something. So let's say, firstly, let's pick some array. Just let the array be 0 indexed, A0, A1. For now, let's not care what elements are there. Let's just consider any elements in the array. Let's say 8 length array is there. So now we know that from any L to R, if we are considering the subarray, then for AL, it should be for A, basically AL will be picked by first person. That is first element, then third element, then fifth element, and so on will be picked by first person. And all other elements will be picked by second person. So can we see it like basically first person score should be perfectly equal to second person score, right? That means first person score minus second person score should be 0. Right? This should hold. So what we can do is we can assume positive as we can just add all the first person score and subtract all the second person score, or even reverse will be the same, right? Second minus first will also be 0. So we could either consider positive for second person and negative for first person. So ultimately, if we look at the array, if we start the array from here, this will become positive. Next, it will be negative. Next, positive. Next, negative. Next, positive. Next, negative. Basically, adjacent elements should have opposite signs, because we just saw f minus s will hold 0 or s minus f will hold 0. So both the adjacent elements, one of them will have one sign and other one will have the other sign, if we look at this particular equation. So because of that, what we can do is we can just give the signs here. We just observe that adjacent, we just observe that for this equality to satisfy, if we consider adjacent elements to have different signs, something like this, then now if we see, there should exist a subarray with some perfectly zero, right? From this equation we can observe that. So if there exists a subarray with some perfectly zero, then we can say for sure it is possible to pick such a subarray which satisfies the conditions.
And when we say subarray, we are saying subarray with respect to these signs.
Yeah, with respect to these signs. Yes. So let's say this is our subarray. Then basically A2 plus A2 minus A3 plus A4 minus A5 plus A6. Whatever this is there, the result should be zero.
Yeah.
Then we can say that like these two people can pick such a subarray. So now let's see how we can solve the same thing. Now the task is, we just saw, after giving them this signs from these observations, there should exist a subarray with some perfectly zero, right? So now we can't do a brute force by fixing every start point and iterate, right? So now let's find the same thing out with prefix sum. So if we relate it with prefix sum, then sum of a subarray can be written as PR. Let R be the rightmost index and L be the leftmost index of the subarray. Then we can write it as PR minus PL minus 1 prefix. P represents prefix. And we take prefix sum according to these signs only. So PR minus PL minus 1 should be 0. Right? Then we can say it is possible. So for this, if we observe, right? So for this equality to hold true, PR should be equal to PL minus. So now what we can do is we can fix rth point and then check if there exists any PL minus 1 which is equal to P. So to fix R, we can iterate one loop, which will cost us N. And then we can maintain a structure like set to check if there exists PL minus 1 which is equal to the current fixed PR. So now basically we are just building the prefix sum and then fixing a R and searching for L minus 1 if there is any L minus 1 which is PL minus 1 which is equal to PR. And one more thing, we should only search among those prefixes which are lesser than PR, which are lesser than R. So L should always be lesser than R. So that way we are just finding out if there exists any pair. So now let us take a example to drive for better understanding. So we can pick a sample itself. So let's say we are picking n is equal to 9 and the array values are 2, 5, 10, 4, 4, 9, 6, 7, 8. These are the array values. Now let us give signs to them, positive. Yes, so plus minus, plus minus, plus minus. Now in this, there should exist a subarray with some 0. Right? So now let's see how we can do. Firstly, let me construct the prefix. So initially in the prefix, let's put the first element as 0. So our prefix will be 0, comma 2, comma then it is 2 minus 5, which is minus 3. Then it is plus 10, which is 7. Then minus 4, which is 3, 7 again. Then it is minus 2. Then 4. Then it is minus 3. Minus 3 and then it is 5. Right? This is our prefix array. And initially we are putting 0 because if L becomes 1, then L minus 1 will be nothing. Right? So to handle the case, like if we pick an empty subarray, the sum of that will be 0. So this represents an empty subarray. This represents a subarray whose a prefix array whose length is 1. This represents the prefix sum of the array whose length is 2, and so on. So now let us see how we can solve this. Let this be my R. For now, let us maintain a map also, map or set, anything. So for now, I'll just maintain a set because we just want to know if there exists any sum which is equal to the current term. Right? So let's say S, I have a set S, and initially the set is empty. Right? So assuming searching in set will take log n, we are doing this. So now this is my rth point which is fixed R. L and R can't be same, right? So because L and R, okay, L and R can be same, but L minus 1 and R can't be same because we are checking for a fixed R, we are checking for L minus 1. Right? So that is why we are fixing R here. If R is this, then in the set there is nothing. So this R is not possible. When so I'll just write here R is 0. If R is 0, then prefix of R is 0. So there is no 0 in the set. Set is empty. So this is not possible. Now R comes here. If R is at index 1,
we should also push 0 inside the set.
Yeah, right? We should also push 0 inside the set. So now the set becomes 0. 0 gets added when R moves here. So PR is 2 and 2 is not present in the set. Now R2, R moves over here. So we put 0 and 2 into it. So minus 3 is not present in the set. We'll just check if it's present or not. In this case, prefix R is 7. So 7 is also not present. So that means till now we didn't find any subarray whose sum is 0. Seven. So in this case, yeah, would be 3. So if we look over when we move R over here, uh, we can see there is no 3 in the S. So now we move R further until we find some subarray. Now in this case, PR is 7. Right? So if we see 7 is present in this, that means there is a prefix L minus 1 which can be paired with prefix R to sum up to 0. So here we need not proceed further, right? Because we already know there is one subarray. We just need to find if there exists at least one subarray. So here we can just output this. And in case we didn't find it here also, we proceeded until R reaches N. And after fixing all n prefix points, still we couldn't find any prefix L minus 1, then that means there is no such subarray. So in that case, it would be a. So this way we can just implement it, maintaining a set and maintaining a prefix. So if you look over the time complexity would be big of n log n. So n, because we'll construct a prefix and we are fixing every prefix point. And for every prefix for every prefix of right point, we are searching for prefix of L minus 1. So that search will cost us log n in this set. So we can say time complexity is big of n log n per test case. And space complexity depends on how you implement. So we can implement this with O1 space and ON space. To construct, if we construct prefix and store, it takes O1. But we can even use a running variable.
But okay. Still we are using a set, right?
Yeah, still we are using a set. So yeah, we can say it's big of n. Big of n in the worst case. But we practically, if we construct some prefix array, it takes 2 into n memory. To reduce one of the n, we can use a running variable instead of maintaining prefix. So, so we can say the space would be big of n. These all are per test case. So this way we can solve the problem. And if we see n depends on the test cases. So though there are 10 power 4 test cases, it's guaranteed that summation of n will be less than or equal to 2 into 10 power 5. So we can assume there is one test case with n perfectly 2 into 10. That will be the worst case, which is still sufficient to pass in 1 second. So this way we can solve it.